Hello, this is DXR. I would like to show you my concept from the very old time, more than 20 years ago, that I called Comtur. The name is because of Polish conclusion to change in the power supply only stage. So what I'm proposing is not to use any channel left or right to our purposes, but only changing the power supply stage. This is for full stereo audio receiver. So this might be, if you succeed, self-sustain. So what we need to change? This is a typical power supply of a stereo amplifier. It can be more multi-tapped here, more taps of the transformer, but we will concern on this that supplied the ending, the power stage. This is mostly like plus, minus, and ground the mass. So this is a transformer, this is a bridge rectifier, and two capacitors here, plus, minus, and ground. So we will add two 10 kilos resistor to higher the capacity. This is one thing. We will use a grabber, any grabber of about 110 tons. This is minimum. And I think it can be done neatly. Not even sometimes if it's not allowed the the direction of the coils, because it should be connected direct with the right direction of the coils, the grabber, but it might be even sometimes with some angle to the existing coils, but only if the GABA trick is used. So that means setting by diodes or even bridge rectifiers, even better maybe, the minuses of the capacitors on PCB in the power stage, in another stage, 1, 2, 3, or 4, maybe not more than 4, but I think 2 or 4 are fine. And I think, but I don't remember much, if I weren't used something like GABA here on the grabber, but I was using something like this on the neutral part of the main transformer. So I was taking minus from bridge rectifier, and via dioda, this is much important, that via dioda I was putting it to neutral. But this was only when the system was used as a generator, and it was only start from phase, from live, and wasn't powered from AC socket the whole time. So I think the only change here is that the grabber that we were using in a three-phase system is used here by a step-up transformer to energize the main transformer. So this is the trick I was using once, and it might be very powerful, enough powerful with the Noplis trick. You might go through with the Noplis, but I want to show you some change, some modification that I was using. I was taking from live by 10 kilo resistor, just taking the signal, making a Noplis here by some, I think, 50 turns on existing capacitors, and by 1 mega ohm I was getting back to chassis. But I found the chassis was somehow kicking me with the current. So I thought I might use a Kapanadze coil, a little plastic tube, let's say 30 millimeters for 200 millimeters long, a plastic tube. And I put about 200 turns here by a normal wire, insulated. Let's say it was some 0.5 millimeters squared, I think, or less. So yes, this was one. And on this I put also the output coil that was about, I think, 100 or not less than 80 turns. Here you might correct the voltage output on this. And this was a kind of a transformer with Kapanadze resonance, Tesla resonance. And I was energizing the transformer. I don't remember if I was energizing this side or this side, but it depends on the voltage that you achieve. So you need to measure the voltage first here. But to get it to work, the most important thing is the third winding. So it consists of 200 windings, some 100 winding, and 100 winding that is normal go through live. So you take live, maybe not here, but some place like here, or like here. But in my drawing, it's maybe not that. It's not that bright to see, but I think it's obvious. So third winding, to make the resonance to work, is to put the live here, just like in Noplis you normally take 2 points, live input, live output, and winding about around the capacitors. You just make some winding on the plastic tube. So this is it. And you start it from phase, and this might really solve for work. But I think the absolute minimum of this resistor is some 550 kilos, because if less, then it might the chassis would be on the live, and this might burn out the PCB devices, because the minus of the ground is mostly connected with chassis. For example, in Paula's baby, it was a trick. If you put the work the right channel, it was a trick that you cut here and use here some, I think it was, I don't remember, it was a 5 kilo or 50 kilo resistor, but I think 50 kilo resistor would be fine. Then sorry, it was somehow better sucking the neutral. I forgot it to describe on my previous work, but you might try this trick. It works, it is universal. It is mostly between the, even sometimes between the ground, in the, if you have amplifier that is insulated and the ground is connected by the wire to the chassis, and if you know, for example, if you have sockets like DIN, so plastic DIN, so Unitra Polish Unitra has had such solution. So this was connected only by wire between ground and chassis. So that means you might use resistor there, but in modern stuff, for example RCA sockets or other sockets, that means has on it the ground, are connected to PCB straightly by mounting. So this is you know, not the best option, I think. But the minus output of the PCB, of the channel, you know, of the power stage of a channel, is something different, because you have the O application and it has the plus and minus for speaker. But the minus output is mostly connected straight to chassis, straight to PCB mass ground, and if you use resistor there, it will suck our neutral better. I didn't test out this circuit with turn up circuit. I'm talking about this strange Noplice with this 1 mega ohm, because chassis is then somehow connected, you see, to the live. But it's all for the purpose of this Kapanadze coil here. This is not connected, this L1 is phase go through, it's not connected to the ground. And you use a polycap, I think 100 nanofarad here on this first winding. I didn't test with turn up, because turn up is energizing the chassis, and I think the chassis might be enough energized here. Simply turn up is using mostly capacitors to work, and high resistances. So this should be safe anyway, but I didn't test it, so I don't know. And I am aware if this can work really, and it's important, I think, that this should be neutral side. Here the NISMA might be used, or any other saving electricity circuit, or sucking the neutral. Here might be some changes to save the electricity for the you know, for the device, what device is using. And here, after the second stage of the main transformer, before the PCB, after, let's say here, after the capacitors, or even auto stage, some modifications might be used. I was proposing something like this, like using more diodes, using some caps more, like poly caps, I was using mostly more diodes here to save the energy that the PCB, that the output device was using. And I think this can be helpful. But I don't remember much how the application was. It was many years ago. But I'm really I'm really curious if this trick with minus via diode and mine transformer might work, just as with this GABA works. Yeah, and I always called it something like contour or something like this. I don't know if this is safe or it makes any sense, but I think still this should be minus, not plus. So don't even start with plus, start with minus, even if you want. But still, if you use this should be a power diode, I think. Still, if you use mine socket supply, just don't bore your head with this solution. But if you use it as a self-sustain, this might even make some sense. So, and this is all. I hope you will succeed with Kapanadze resonance. Here you might tune it with somehow with this changing the capacitance of this capacitor, and three windings on each other. From it, if you make a Kapanadze coil like this, like Barbarella or anything, on 30 millimeters plastic tube, you go always from one side. So this means you go always from the left to right. So and the direction of the winding should be the same. So you go one, insert another. If you end in half, you end. And third, and this should be done like the highest turns, medium turns, and low turns. So if you make a Kapanadze coil, go from one side to another. If you have spare place here, this is okay. The most important. So as you can see, the most plastic tubes of Kapanadze looks like, you see, like something like this. Something like this. Yeah. They look something like this. Yeah. So you go from one side. The direction is the same. Unimportant is the diameter. Sometimes you might put the ferrite cores here, or ferrite bytes. I'm talking about something like this. The ferrite rings, yeah. And I think up to 70 millimeters. This will work up to, let's say, 75 millimeters. The resonance still goes on, and it goes from something like 33 millimeters. Yeah. So this is all for now. I will scan this page and put it on my disk. So have a good day and bye bye.